Okay, I'm going to go ahead and clear my IP NAT translations from our previous lab. And let's see if they were actually cleared with the show IP NAT translations. Next, I'm going to make sure PC3's address is 10.10.10.3, which is not. If you remember our router on a stick lab, PC3's IP address was 20.20.23. Let's put that in the 10 network and change our default gateway to 10.10.10.254. Now let's just do some preliminary testing to make sure this worked. IP config /all to check the IP. Missing an I. And my IP address is 10.10.10.3, and my default gateway is 10.10.10.254. Let's ping the default gateway. The first ping should time out for the ARP request reply process, and then it should start pinging. No, actually, it is not going to, because we have to change the switch and put this switch port in VLAN F0/3 in VLAN 10 instead of VLAN 20. So if you look at my switch, show VLAN brief, you see that F0/3 right now belongs to VLAN 20. Let's change that over. So int fast ethernet 0/3 switch port access VLAN 10. Do show VLAN brief. If I can type it, this would be easier. Okay, so switch now. Port 3 has been moved over to VLAN 10. PC3 should now be able to ping. As you see, guys, when you make these changes, be aware of your layer 2 also. So the first ping should time out now, and then it should start pinging. If Packet Tracer is going to be kind to me. And there we go. The first two timed out, but now it's pinging. Now, I'm going to translate PC3 10.10.10.3. to 190.10.10.1. I'm going to pick the first address and translate it to 190.10.10.1. So let's go into router 2. I could say to 190.10.10.3, but I want to show you something aside from static NAT. I want to show you that if I translate 10.10.10.3 to 190.10.10.1, then when PC 1 and 2 go out to the outside world, the router 2 is basically going to pick the next available address, which is going to be 2 and 3, 190.10.10.2 and 190.10.10.3. So the command syntax for static NAT is IP NAT inside source static. So IP NAT inside source static. If I say question mark, it is asking me for the inside or the local address. So I'm going to say 10.10.10.3, which is PC3's address, and then my global address, which the address router 2 is going to translate to. And I'm going to pick 190.10.10.1. Now, 10.10.10.3 is always going to be translated to 190.10.10.1. Let's look at our translation table. Show IP NAT translations. As you see, I didn't have to pass traffic before I see translations in my table, because 190.10.10.10.3 is always going to be translated to 190.10.10.1. So I should now, in theory, be able to telnet to 190.10.10.1, and that should telnet me to PC3, which is 10.10.10.3. Let's go to router 4 and try this. I'm going to telnet to 190.10.10.1. And it says connection refused by remote host. Let's try pinging 190.10.10.1. And I can ping 190.10.10.1. So I don't know why it did not let me telnet. Password. Cisco. I have to create a telnet password on router 2 also, because router 2 is going to be the router for any inbound telnet connections to PC3. Router 2 is going to actually intercept those connections or terminate those connections and then create a separate connection to PC3. So router 2 needs telnet access enabled on itself. So line VTY 0 space 15, password Cisco, login. Let's check router 4. Let's try and telnet again from router 4 to PC1 using PC1's global address, and it still won't let me, so maybe this is a packet tracer thing. I will simply ping to test this. Ping 190.10. Well, let's do an extended ping. We'll type in ping protocol IP to target IP address is 190.10.10.1. Repeat count, I'm just going to set it to 500 so my translation table doesn't time out and I'm constantly sending traffic. And I'm going to constantly be pinging from router 1. Router 2 still has the translation table. And now as you see, 10.10.10.1, 10.10.10.3 is constantly being translated to 190.10.10.1. And with every ping, I'm going to get a translation. And if you see, my first two translations actually did happen. 10.10.10.3 did get translated to 10.10.10 and 190.10.10.10.1, and it was a TCP telnet connection to port 23. So even though Packet Tracer had a bug in it and did not show us that the telnet was actually happening, router 2 still did perform the translations. Now at this point, if I go to PC 1 and 2, and I telnet to router 4, and I'm inside of router 4, and from PC2, I'm going to telnet to router 4, and I'm in router 4. If I check my translation tables on router 2 again, now we saw that PC3 or router 2 is translating the 190.10.10.1 address to which we are sending the pings to from router 4. So router 4 is always translating to the 10.10.10.3 address. What if PC1 and PC2 try to ping router 4 also? Let's find out. From PC1, I will ping router 4, and PC2, I will ping router 4. And if I check my translation table, PC2 and PC2 and PC1 are still picking the .1 address, which means I am not sending any more pings from router 4. Let's restart our pings from router 4 to the 190.10.10.1 address. Repeat count, we'll make it 1,000 this time. And now let's ping from PC1. And I have to do this quick before this times out on Packet Tracer. And I'm going to ping again from PC2. And if I check my translation table on router 2, so as we see, PC3, or when somebody from the outside world uses the 190.10.10.1 address to send traffic inbound towards PC3, router 2 always translates to the 10.10.10.3 address, because that is hard-coded into router 2 to statically change the 190.10.10.1 address always to the 10.10.10.3 address, and vice versa. This concludes our static NAT lecture.